Okay, now we're moving on to that the hypothesis test of proportion. Okay, so as we know, the proportion everything involved in the percentage. All right, so that's what we're going to analyze for the two samples or two uh, different sample of or cluster of the samples. Okay, now as we know that the testing a population proportions, you should recall that when the variable measure nominally, we can only use the statistics based on the count of the frequencies. So this is important. All right, so nominal data, we should use that the frequencies. Later on, we convert into percentage. Okay, a way of represent the count of frequency with that we call as a proportion, and the proportion is fraction is or percentage indicate that the part of populations, okay, is a part of population or samples having the particular trait of the interest. Okay, so the proportion will be represent that the sample as well as the population. All right, based on the frequency value that we obtain, we come up with the percentage which is represent that the population and samples. Okay, and then the sample of proportions denote by that the p value. Okay, the sample proportion is denoted by the p value. I'm sure you all studied that before in the last week class. We just use the same notation for throughout the subjects. So the sample proportion denoted by the p is found by, okay, we can get it from x over n. Okay, based on the formulas. And then, okay, the x is the number of the observation with a particular trait, and the n is the total number of the observation. So we can get that the proportions for the samples. And then the population proportion is denoted by the pi value, pi symbol. This pi, okay, we call as a pi. So this is a symbol they use for that, the population proportion. Okay. All right. The random samples is selected from the population that follows the binomial distribution. You should remember this. Okay. Again, we already done that the very detailed analysis or discussion in the previous lecture. So you should know that the random sample selected from the population that follow is the binomial distribution. Okay. So that means that the binomial distribution requirements, okay, based on that, the data accounts the nominal variables for the, and then the outcome of each observation is classified into of the mutual exclusive success or failure. All right, you should have the two different estimating difference, okay, in that understanding, and then the probability of the success is the same for each observed value. Okay, so this is a third condition. And then the fourth condition of the observation are independence. Okay, so that is the four requirement we need for the binomial distribution. Okay, when both n and the pi and n1 minus pi are at least 5 and above requirements are met, we can use the normal distribution. Okay, because we assume that it will be approximate to the normal distribution. Okay, all right, so this is the condition we should know in that the population proportion. Okay, take a look at this example. Suppose prior election in certain state indicated that it is necessary for the candidate for governor to receive at least 80% of the vote in the northern section of the state to be elected. In incumbent, our government is interested to assessing that its chance of returning to office and plan to conduct a survey of 2,000 registered voters in the northern section of the state. So it means you can see that here they're going to do that the testing whether you're going to win in the election or not. Okay, so based on the 2,000 registered voter, using the hypothesis testing procedures, assess the governor chances of that re-election. So say they want to say re-election, So they want to see in what whether he can won the election. If is at least 80% of the vote is achieved, then he will be won the election. Okay, now we do the testing. Your first step, you should know that state all the null hypothesis and an alternative hypothesis as usual. All right. So as we know that the key important words, as we see, at least 80%. This is the key point when it's very useful when we just develop that hypothesis statements. At least, what does it mean? At least, okay? So you should have at least symbol which is less or equal 0.8. So 80% means we convert into the percentage to decimals. You got a 80 over 100, so you get a probability value which is 0.8. So that means that at least that the decision to reject the null infer that the governor will not be re-elected. Okay, so if it is less than 0.8, it's not going to be happen. So the mean as you said the hypothesis alternative, which is the, you can say the pi or proportion population less than 0.8. So it is true, then he will not elected in the election. Okay. Alternatively, the null hypothesis. So you can write that the population proportion is greater or equal than 0.8. Okay. All right. So when you set this, second step, set that there's a level of significance. Okay. We choose that 5% significant levels. Okay. So the alpha value is 0.05. Third step is need to select the test statistic. So since your n pi value how much? Okay, so it is 2000 times 0.8, so it's considered as greater than 5. So we choose that z distribution. Okay, we use the z distribution. Okay, so 2000 times 0.8. Okay, so we got around 160, something like that, right? Okay, so then since it's greater than 5, then we choose that the z distribution. Okay, first step. Okay, so remember the formula, recall the formula, the one I taught in the one sample T hypothesis testing. So you use the same formula. So sample proportion, okay, sample proportion minus that hypothesized population proportion, okay, the pi over square root of pi in bracket, okay, pi multiply in bracket 1 minus pi over size sample or sample size. Okay, so once you do that, write in formula. Next, step 4, formulate the decision rules. Okay, so we have that the z value. Okay, so z value at the point the 0.05. Okay, so it is the both side. Sorry, it is less. Okay, so that means we just take the left hand tail. Okay, because this is just okay, at least means the hypothesis that is less. Okay, so that means we just take that this region. So the critical value at the point 0.05, okay, is the value is z alpha. Okay, the alpha is 0.05. Okay, so we got minus 1.645. Okay, this region, the critical region. Okay, so now we do the testing. If we reject, the value is less than the critical value minus 1.45, then we reject. Okay, so now we calculate that the z value. So using a sample, now we do the analysis, and after that we do the decision. Okay, so we know the formulas for the proportion population, all right, for the distribution. So substitute the value. This is your x over n. Then you get the population proportion. So minus 0.8, okay, over 0.8 in multiplied by 1 minus 0.8 over 2000. So you get a minus 2.80 after simplifying that entries. So minus 2.80. Okay, so Z value already obtained, minus 2.80. So 2.80 is considered the less than minus 1.642. Okay, that means the Z value obtained is less than your critical value of alpha. Okay, so which means we're going to reject. Okay, so the computed value, which is minus 0.28, is in the rejection region. So that null hypothesis is rejected at the 0.05 level. Okay, so 0.05 level or 5%. Okay, and then the interpretation, you can say that the difference of the 2.5% point between the sample proportion is about 77.5, and the hypothesized population proportion 80% is statistically significant, so that the evidence at this point does not support the claim that the incumbent governor will return to the governors mentioned for another 4 years. That means you may fail in the election. He will not elected in that election. Okay, so that is the interpretation you can give based on that value that you obtain. Okay. Two sample test of proportion. Okay, the example also we can give like the vice president human resources wishes to know whether there is a difference in the proportion of the hourly employees who missed more than 5 days of the work per day or per year at Atlanta and the Austin's plant. That means the two places. Okay, so we have a two different set of data. Okay, this is another example. Okay, so General Motors considering the new design for the Chevrolet Camaro. The design is shown to the group potential buyer under 30 years of age. Okay, 30 years of age, and another group is 60 years of age. So two different set of data. So is a difference in that the proportion of that who like, so that means the equal, all right, two-sided, two tails. So third example is a consultant to the airline industry is investigating the fear of flying among the adults. Specifically, the company wishes to know whether there is a difference in that proportion man versus woman. So two set of data, woman and man. Okay, to see their fearful of flying. Okay, so these are some examples you should know in order to identify that the proportions. Okay, so yeah. All right, to test the hypothesis about the difference between the two population proportions. So again, use the normal distribution to approximate the binomial distribution, and then use the ZT test, okay, or ZT statistic to compute. All right, okay, so two sample tests of proportion. The return Z equal to P1 minus P2 over square root of, this is your PC in bracket 1 minus P is the population proportion over X1. So it's set data 1 plus, and then population proportion, okay, 1 minus PC over, and the size of sample data 2. Okay, all right. So this is that the given pool proportion. Okay, the PC that denote as the pool proportion processing. We combine the two samples of data. Okay, so we can also get the population proportion. Okay. All right. So once we know that the formulas, next you need to know the denominators. Okay, at the standard deviation of the P1 minus P2 now is include PC. Okay, which that the pool estimate of that the population proportion. So you should aware on that. So this is the PC. Okay, now the population proportions combined Okay, it's already estimate the N1, N2. So usually they use the different formula, right? So N minus 1, something like that. So it's include that in the full standard deviations. Okay, full standard deviation for the combination. Okay, the pool or estimating the population proportion, the formula is this pool combinations population proportion equal to x1 plus x2 over sample of number size sample 1 and plus size sample 2. Okay. Okay, the given is that all the information. Okay, so you can cross check with that. Okay, take a look at this example. Manali Perfume Company recently developed a new fragrance that is planned to market under the same Heavenly. A number of market studies indicate that Heavenly has that very good market potential. Okay, now we're going to evaluate. The sales department at the Manali is particularly interested in whether there is a difference, okay, okay, in that proportions of the younger and older. So we're going to collect the data. We must have a data on the younger and older women who purchased the Heavenly if it were marketed. Okay, so they're going to check is different. That means equal or not equal. Samples are collected from each of these independent groups, and each woman is asked to smell the Heavenly and indicate whether she would purchase that fragrance. So now we're going to do the analysis, use a different set of data. One is from younger woman, another is older woman. Okay, now, first, what all you need to do, you need to follow the step 1 as usual, set that the hypothesis null and hypothesis alternative. So we do that. These are keywords. Just now we just read is a difference. That means an equal. So we set that the younger woman, okay, and the older woman. So the pi 1, okay, so is equal to pi 2. This is what I assume. And then for the alternative, we not agreed. Okay, the alternative hypothesis that is not equal for that young woman and older woman. Okay, so that we just denote that as a alternative hypothesis. Second step, we're going to set the significant level, which is 5%, which is 0.05 for the alpha value. And then the third step, we're going to determine appropriate test statistic. So we use that the Z distributions to approximate that binomial distribution because the sample size are relatively large. Okay, so we can say that yes, we have to use that the Z distribution. Okay, all right, now we're going to formulate the decision rules. So decision rules, we said that if it is greater than the Z at the critical or significant levels or less than that at the significant or critical level, so that means we reject. Okay, so we're going to do that. All right, so we look at that the value for the significant levels for Z alpha over 2, which means 0.025. Okay, so we obtain the value is minus 1.96. So we get a critical value at this point. So Z, okay, so this is a Z value 0.025. We got a minus 1.96. Okay, now we're going to do the test. Okay, we collect the test and then do the analysis and then we make a decision. So let we do that the P1 is equal the proportion of the young woman. Okay, P1. And then the P2, we denote the proportion for the older woman. Okay, we denote the P2. Okay, and then we execute the calculation. So P1, X1 is 19 over 100. So we got a 0.19. And then the P2 is X2 over N2, which is like 62 over 200, so 0.31. So you have P2, the older woman. Okay, now we got a combined proportion, population proportion. So we add the two, okay, x together. So x1, x plus x2, we got 81 over x1 is plus x n2, n1 plus n2 is we get a 300. So we get a 0.27, which is PC. And after that, use the t-test, z-test. So use the formula, okay? So P1 over P2 over square root of PC in bracket 1 minus PC over N1 plus PC1 bracket 1 minus PC over N2. So we just add all this value into it, okay? And then we just simplify all the entries. So we get a minus 2.207. This means the Z value is minus 2.207. Now we need to compare with this value with the critical result. Okay. So the critical value, as we know that just now, is minus 1.96. Okay. All right. So the value you obtain, which is Z value, okay, is minus 2.207 is the area of the rejection. Therefore, the null hypothesis rejected at the 0.05 significant level, because this value is, Z value is the T we just obtained is a minus 2.207 is less than minus 1.96. So this, since this is the condition what we obtain, so then we have to reject that the hypothesis null. So the interpretations, you can say that the proportion of young and older women who purchase the heavenly are different. Okay, and you can say that, you can add on by observation, the proportion indicate that the older women are more likely to prefer the fragrance, okay, the fragrance compared to the young ladies. Okay, so based on this proportion, you can see that. So based on the proportion we have, the older woman is buying more compared to that the younger woman. So in that case, we can conclude that we reject that hypothesis now. So we can conclude the older women prefer more fragrance compared to the young women.